right. So if you're on a roller coaster and you have points A, B, and C, what is your potential energy at B when you're on the ground? 0 joules. Very good. Y'all are so smart. What about if you're at A, an instant before you start to fall down the track? What is your kinetic energy this time? Not your potential. 0. Okay, so what we can say then is at point A, your energy is all potential and no kinetic, right? You can say that about A. So, at B, do you have any kinetic energy? No. I'm sorry. Yes. Do you have any potential?
No.
So, all kinetic, no potential. Bless you. Okay. At point C, do you have potential?
No.
Yes. You have height. You don't know what it is, but you have a height. Are you going to be moving at point C?
Yes.
Yes. So would you have kinetic? So at point C, well, you don't know because you don't really know that height yet. So both potential and kinetic. Any questions about this so far? It's pretty straightforward, right?
Yeah.
Okay. So remember, energy is conserved. So the mechanical energy at the top is equal to the mechanical energy at the bottom. Remember, in this case, me is mechanical energy. It really just means for right now the total energy. Energy. Okay? So, at point A, if the cart is 82 meters off the ground, has a mass of 120, what's the potential energy of the cart? What is my formula for potential energy? Mass times gravity times height. So UG equals 120 times 10 times 82. 98,400 joules. At point A, what is the KE?
What did you say?
At point A, what's the kinetic?
0.
0. Before you start to fall, your velocity is 0, so your kinetic energy is 0. Now, remember, your total energy, your mechanical energy formula is ME equals KE plus UG. With that being said, what is your mechanical energy at A? 98,400 joules. Okay. Everybody with me so far? So far, yes. Good. All right. What is the mechanical energy at B?
0. 100.
98,400.
Is that me formula?
I can put it there. And at C? 98,400. There we are. Remember, energy is conserved. The first law of thermodynamics, energy cannot be created or destroyed. It can only be transformed. So at any point in that closed system, this entire thing, at any point, wherever you stop it at, the entire mechanical energy is going to be the same value. Okay. If the kinetic energy at C is 65,600 joules, what is the potential? How did you find that? Perfect. So he used mechanical energy is equal to kinetic plus potential. He did 98,400 equals 65600 plus potential. I'm sorry, it's getting a little squishy. Can you say it louder? What was it?
32,800.
So this is a subtraction. Remember, when you're looking at a formula like this and you need to get a number to the other side, you have to do whatever's opposite. If it's multiplying, that's division. If it's addition, it's subtraction. Any questions thus far? Okay. Let's look at our skater boy. All right, so this looks like a whole lot of blanks and not enough information, but we actually have everything you need to solve it. The first step is going to be to find the energy at position number 1, which is right here. So at position number 1, he's skating on the ground. Does he have any potential energy? He might have potential, for his future, but potential energy, no. So we're going to put 0 joules. Okay, now I do not skateboard. I am lucky if I can walk without falling. But this little dude would go up his little ramp, and just for a second before he starts coming down, it stops, right? At that instant, does he have potential energy? Yes. Does he have kinetic?
No.
Nope. Just for that instant, his kinetic will be 0 joules. What would be his velocity just at that instant? 0. Okay. Now it's starting to look a little bit less blanky, but we still got some things to fill in. Right here, this tells us his mass is 60 and his velocity is 8. So we are going to find his kinetic energy at number 1. So at 1, KE, remember it's 1/2, which because I'm an adult, I don't have to use fractions. 0.5 times mass times velocity squared. So KE is equal to 0.5 times 60 V squared. Times, you squared his velocity, 8 squared. I got 1,920. Cool. Is that what you got back there?
Yeah.
Yeah, no doubt. No doubt.
Actually, I guess I'm good.
Did you square your velocity?
No, that's why I got
Okay, we gotta make sure that that little 2 counts. So I'm gonna put my kinetic energy there, 1920 joules. What is my total energy? 1920. All right. Stuart, what's my energy at 2? What's my ME at spot 2?
19.
Stuart is going to answer me. Very good. 1,920 joules. What's the mechanical at 3? What you got?
19.
Y'all are so smart. 1,920 joules. I don't even need to be here. I can just go home. Y'all got this.
If you want to.
Yeah. Uh-huh. All right. So then we are left with these blanks, right? Do we want to do 2 first or 3 first? It really doesn't matter. 2. All right, 2. So at 2, I do not know his velocity. It does not say. But it does give me a height. So at 2, what formula can I use that involves height? UG. UG equals mass times gravity times height. So his UG is equal to 60 times 10 times 1. I don't want to brag. What happened to that 600? Yeah, I know. Y'all are just amazed.
It's like 3 numbers.
So I'm going to put that up here. 600 joules. How do I find my kinetic energy now.
Subtract it.
Subtracting from, so ME equals KE plus UG. 1920 equals KE plus 600.
Prof, is this step 3 or you're just like doing extra? Is it part of step
This is 3. I'm just trying to keep it in the screen though.
Oh, yeah.
So remember, when you need to move it to the opposite side, you have to do whatever the opposite direction is. So this is a plus, so we're going to subtract. 1920 minus 600 gives us
1,003.
What do I do to find my kinetic or my velocity then? Very good. I'm going to use 1/2 times mass times his velocity squared. So that's going to be 320 is 0.5 times 60 v squared. Half of 60 is 30. So I would take 1320 and divide it by 30. What does that give me? 44
44.
equals v squared. Now what? Square root both sides. What is the square root of 44, please? 6.6 meters per second. And we are almost done. Just to keep this, y'all can continue writing on that same page, but to keep it all in the frame. The 600 came from, I solved it using my height.
I thought we got 1320 for that.
What? 1320 was the KE. Yes.
Yeah.
Okay. So, if at 3, 1920 is my total energy and my kinetic 0, what is my potential? 1920. And what formula do I need to use to solve for height? UG equals mass times gravity times height. 1920 equals 60 times 10 times H. H is 3.2 meters. Now, if you know nothing else about me, you know I do not lie to y'all. You will absolutely 100% have a roller coaster similar to this on your test next week. 100%. You are going to be expected to know how to do this. Okay? There's no way around it.
The whole thing.
Whole thing, baby.
All that we did.